Did you guys all celebrate Cinco de Mayo with some Mexican food?
No.
Yeah. No. Tres amigos. What'd you get? Oh, the habanero chili. Brave, bold. I know. So by the time you graduate from Burns, if you don't take any more algebra classes, then you won't get like a full blown like 4 week unit on this because we do that in algebra 2. But you'll learn lots of different ways to solve these equations. I'm going to try to get 3 of them to you this year. So the first one that we're going to learn today is solving by factoring. And I want to keep this separated. So that's why you get one quiz just over this. And then the other ones that we'll learn next week are a little bit trickier. And therefore, when they are for when what we're learning today doesn't work. So today's method is great when things can be factored. And everything today will be factorable, just for the record. But if you come across something, don't write this down, but if you came across something like this, like you cannot factor, not using whole real numbers, you cannot factor this. Like if you tried the whole build the shells thing and put your x's in there, you cannot find numbers that multiply to make 2 and then would also satisfy the 4. So next week, when we learn about the quadratic formula and completing the square, those methods generally are reserved for when what we're learning today does not work. So that's just sort of a heads up. But all of them today, I have lots of examples for you today. All of the problems today and tomorrow are going to be factorable. So no trick questions, okay? All right, let's get to it. So the idea is this. Everything now for the next 3 or 4 days in this class stems from a very basic mathematical principle. It's called the zero product property. And it really helps to understand this before we press on. So if I told you that I was thinking of 2 numbers, A and B, and when I multiplied them together, they equaled 0, then what would have to be true? One of them has to be 0. I mean, maybe they both are, right? But at least one of them. So either A equals 0 or B equals 0. And you might wonder, what does that have to do with anything? Well, it has everything to do with what we're talking about. If 2 things multiply together to make 0, then without a doubt, at least one of them has to equal 0, correct? So don't forget that as we dive into today's lesson. 2 things multiply to make 0, at least one of them has to equal 0. We agree. Okay, so having said that, this is a quadratic equation. All you've been working with for the past week or so have been what we call quadratic expressions. So if I were to erase the equal sign of 0,
were absent during live processing or did not finish, so please report to the library at this time.
so if all I gave you was x squared minus 2x minus 24, I would ask you to factor it, right? Well, what we're going to do today is with the addition of the equal 0 on this side, we're going to still factor down this side. But what we're going to do is we're going to turn it from a subtraction addition problem into a multiplication problem. And that's going to bring that property at the top of the board into play. So focus only on the left side because we've got the right side equal to 0 like we want. And if we build our shells on the left side, we know we start with x and x, right? So we're putting our skills from before to the test, or to use, I should say. Now, what would my signs have to be? Yeah, like without even a doubt, because they multiply to make negative 24, there has to be one of each. Has to be. That will never be a discussion or a debate or a negotiable. And then what numbers are we thinking of that multiply to make 24 that would make this work? We definitely want a 4 and a 6. And which one do we want to go with the plus? The plus with the 4, I think you agree. Because if what I want at the end of this is, remember, we talked about this all last week, is that I want Mr. Purple and Mr. Green, when I multiply them together and add them, so like Mr. Purple makes 4x, Mr. Green makes minus 6x, I want them to equal what's in the middle. So if that's confusing, then I would just say you probably didn't do enough homework last week. So that's just kind of what we learned. So now that we have factored this down, understand something, that what we have now is exactly what I put up at the top of the board. I have this guy times this guy equals 0. That's what I've done. That's the power of factoring, is it turns addition and subtraction problems into multiplication problems. And now if I said to you that the red thing times the green thing equals 0, you just told me a while ago, you agree that either the red thing or the green thing has to equal 0, right? What makes the red thing equal 0? What I mean when I say that is, what could I put in place of this x right here to make this red thing go to 0? 0 is always everyone's first answer, and it doesn't work. If you change x into 0, right here, watch, I'll do it for you. If I change this into 0, does 0 plus 4 equal 0? No. So I'll ask you again, what do I want to change x into that would make the red equal 0? That is the solution to the quadratic equation. That means that if we go back to the very beginning of the problem, and I'll show you, if we change x into -4, the equation actually works. That's what it's always meant to be, a solution of an equation, is you make the equation true. What makes the yellow thing or the green underlined thing equal 0? Those are the solutions. So we say the solutions to this quadratic equation are x equals -4 and x equals 6. They both make the equation go to 0. And if you don't buy it, just look at these purple arrows up here and let's do some really easy low-level math. If I change both of those purple arrow x's into, let's say, -4, right here, what's -4 squared? Right. And then in the second clump here, the second sort of jelly bean looking thing, what's -2 times -4? It is not. It is +8, right? The x went away and became the -4, and it changed to plus because it's two negatives. And what's 16 plus 8? 24. And what's 24 minus 24? It works. Same thing. If we go up to the top where the purple arrows are and we change them both into 6s, right here, first red jelly bean, what is 6 squared? 36. And then for the second red jelly bean, what's -2 times 6? -12. And then I tack on the minus 24 at the end. What's 36 minus 12? 24 minus 24 is 0. So they both work. I'm not going to do that on every problem. I just wanted you to see that this isn't like witchcraft. Like, this isn't something that we can't get our hands around and actually go, oh, I see that. Like, these are two solutions, both of which make the equation true. We're not used to that. We're used to equations having one answer, like x equals 5 or something. These quadratics will have two solutions. Okay, let's go again. Now, I'm going to give you a couple just easy warm-ups, kind of, that's the goal here for these first few minutes, and then we're going to start branching out and looking at some more tricky scenarios. I say today's lesson will be lengthy, so be prepared for that. Note that it's already set equal to 0. That'll play a critical role here starting in about 10 minutes or 5 minutes even. It's not set equal to 0. We need to fix that, but it is. So hopefully your factoring skills are on point. If not, it sucks. Start with my x's. What are my signs going to be? Both pluses. It's the only way to make this work. And what numbers are we looking for that multiply to make 30? 6 and 5 for sure, 100%. There's lots of numbers that multiply to make 30, don't get me wrong, but we know it has to be those because we're trying to make that 11 in the middle. What then are the solutions to the equation? X equals what? Let me ask this again because I clearly have stumped you. What makes that red jelly bean equal 0? There you go. That's how you find a solution to a quadratic equation, is you make its factors equal 0. What makes this green equal 0? Those are the solutions to the quadratic equation. Put a box around them, hit send, on to the next one. Bless you. Okay. Round 3. Start with your x's. What do the signs have to be? Absolutely not. They multiply to make a positive. They cannot be one of each. They must both be the same, and in this case, they must both be negatives to cater to the guy in the middle. There will never be one of each if the number in the back says plus. Ever. What numbers are we looking for that multiply to make 20? 10 and 2, right? Most people will say 4 and 5, but 4 and 5 you can clearly see. That's why I had you do like 100 of these last week, is that they don't work for the 12, right? This is why we got to be so good and quick and perfect with our filtering. So if I put a 10 here and a 2 here, those are perfect. They multiply to make 20, but we can make that negative 12 in the middle. What are the solutions to the equation then? X equals 10 and x equals 2. Done. Okay. Any questions about that? All right. How about this? If last week was a success, then you have learned that when you see a quadratic like this, it triggers a response. Like you think this is different. This is one of those weird ones, and we should have practiced these quite a bit. How do we make these weird ones without the middle term? The middle one has to cancel, and the only way to do that is to make sure that one of our factors has a plus and one of them has a minus. And again, there's lots of numbers that multiply to make 100, but what are the only two that'll cancel out? 10 and negative 10, right? And if these two factors multiply to make 0, what are the solutions to the equation? And good. And you can use this symbol if you want to. You don't have to, but x equals positive negative 10. You'll have to use that symbol at some point in the future, but it's not right now. So if you're comfortable writing them out separately like this, okay. If you want to use them more condensed, okay. It doesn't matter yet, okay. All right, I'm going to start. Oh, wait, I got to show you one more. What's weird about this quadratic? Right, and this time it's not like the ones that are missing the number in the middle. This time it's missing the number that would ordinarily go right there at the back. So the strategy for this is to do reverse distribution. We call it, what does GCF stand for? Yeah, so we're actually going to pull the greatest common factor out of x squared and 3x. They can both be pulled out by x. I'm going to divide x out of both of them like this. It's interesting, if you see that, what I just did is actually just did the distributive property literally in reverse. By putting the x out front, I have undistributed that x because I'm trying to turn this into a multiplication problem. What's left of x squared if I undistribute an x? And what's left of 3x if I pull out his x? Good job, guys. Now what we're left with is a red factor and a yellow factor. This is always, I do this every year, and this question always is hilariously difficult at first. What could I put in place of x to make the red circle equal 0? You got it. People say the funniest things on this one, but really it's so hilariously obvious once you see it. You just make x into 0 and the red circle goes to 0. That's all I'm trying to do, is make factors equal 0. And if one of them just says x, just change it into 0. And then of course, what makes the yellow egg equal 0? Good. All right, now I'm going to start moving some things around. So On all of these, if you're keeping score here, you'll notice that in all of them, I've set them up as equals 0, equals 0, equals 0, which of course begs the question, what happens if it's not equal to 0? So let's take a look at that. So as you prepare for the quiz that you'll take 1 week from today, you got to start thinking in terms of make it equal 0, make it equal 0, make it equal 0. And at any cost, you're going to make this equal 0. This whole thing we're doing doesn't work if it's not set equal to 0. It's all predicated on your ability to say two things multiply to make 0. So what we're going to do is we're going to take this negative x squared and we're going to move it over to the left-hand side. And the reason we want to do that is so we can get, number one, all the stuff onto the same side with a 0. And then we also never want the red thing to be negative. Okay, so by moving the red thing to the left, he becomes positive x squared. And then I am going to flip these two terms so that my quadratic is in a correct format, standard form. So I'm going to move the minus x just over to the left, and I'm going to move the positive 15. You see how I just kind of shuffled them so that they were in the right order? And now, poof, presto, I got myself a simple pimple factoring problem. Time to build your shells. And here we go. I'll stick in the x's. What are the signs? Both negatives. Again, we know they both literally have to be the same because of the plus. The minus in the middle tells us then that they're both minuses, right? So I need a minus and I need a minus. And what numbers are going to foot the bill here? 3 and 5. There it is. So we prepped it by setting it equal to 0, and then we factored it, and now we're going to find solutions. What are the solutions? Correct. Everybody still good? This example really on my note card came into existence just to make a point. And that point is, I mean, it's a normal quadratic equation, but the point I wanted to make is that x squared does not always have to be on the left. That's a lazy mathematician's habit, is just, oh, it's got to go to the left. It's got to go to the left. And that's not true. So you'll notice that, of course, there are like terms that need to be moved around. I do not want to move the red guy because he's positive. Is that clear? Don't ever make him negative because factoring is kind of poopy if you do that. So always make sure x squared guy is positive and everyone else flows to him. So that means that 10x, you're coming across, 3 minus 3, you're coming across. So my x squared is just going to kind of sit there and wait. How many x's will I have when I move the 10x across? None. Very good, because I'm subtracting it to make it come across. What will my minus 28 become? No, I'm not moving the minus 28. Look at the green arrow. I'm moving the minus 3. So what will my minus 28 become? Negative 25. I just want you to see that quadratics do not have to be blah, blah, blah equals 0. They can be 0 equals blah, blah, blah. Who cares, right? Same, same. Let's factor this down. This is one of these weird ones that does not have the middle. Like Alana said earlier, we have to make the middle cancel out. And we do that by doing 1 plus and 1 minus. And what are the numbers? 5, 5, just like that. One of them with a plus, one of them with a minus. What are my solutions then? Good job. Okay, these next couple minutes are just me bombarding you with, I think I have 4 more examples, and then we're going to get into the hard ones. So like I said, today's lesson is pretty beefy. There's a lot of action going on today. You can see that the left side is where we're going to go this time, right? Because that's where x squared will be positive. So it's always based on where will the big guy be positive. So clearly I have to move negative x over to the left. And don't be a rookie, like it's mace sticks. Like don't forget to change the signs on things when you move them across equal signs. That ship has to have sailed for us. So x squared is going to stay. How many x's will we get? 12, because we're adding that x when we move it across the equal sign. And here we have our factoring. Once you get it set equal to 0, it's green light. So here we go. Build your shells. What are the signs going to be in my factors? 100% one of each because they multiply to make negative 13. And what numbers are we thinking of that multiplies to make our 13? 1 and 13. And who do we want with the plus? Definitely put the strong number with the plus, because when you pay attention to what your goal is plus 12. So you got to give more power, more clout to that positive action. So we want the plus 13 and a wimpy little minus 1. What are the solutions then to this equation? Nice job. Good. Next one. Where will our action be happening, on the left or the right? The right. Good. And we're not going to move that x squared. We like him just the way he is. Moving him will mess him up and turn him negative. So x squared's like, yeah, I'm just going to go ahead and thank you. So how many x's will we have next to him? I assume you all see this guy. I would assume you also see, thank you, Alana, yes, that he has no one to go with. So the plus 10x, it doesn't say plus in front of it, but since it's a positive, that's of course implied. So the plus 10x just slides over to get in his proper location. And what will be the number after the 5 or the 10x? There won't be one, right? Because the 5 and the -5, like they go away. So we're left with a situation that looks like this. And I wanted to make sure to sprinkle these throughout the lesson today, because these get missed a lot. These are the ones that can be tricky because it's not one of those plus and minus things where we're trying to make the middle term disappear. We acknowledge that there's no number right here, and that can freak us out a little bit. Who remembers from about 10 minutes ago how we attacked these? Good job. Good job. Great job. These are the ones where you factor GCF, call it undistribute, call it whatever you want. So pull out. You take out of both of these two terms an x because they both have it to give. And what's left if I pull x out of both of them? X plus 10. Nice. So once again, I find myself in a very obvious situation where I've got a red factor and I've got a purple factor. And how do I make the red factor equal 0? With a 0. Very good. So one of my solutions is 0. How do I make the purple factor equal 0? Nice. Still good? Getting the flow. All right. Next one. Left side is home base, eh? Right? X squared's good. Leave them alone. So everyone's saying, all right, we'll come your way there. Holmes, we're coming to you. So how many X's will we have next to this guy? -9. And what will the number be after that? There won't be one, right? Because when I add the 2 away to both sides, they go away. So look, I got 2 of these in a row for you. Because that last one, I know I only heard like 2 people say this correctly. So how do you do these when the number in the back is missing? When the number right there is missing, how do you do it? Undistribute. Very good. So we're going to yank that x out of both of them. And what does that leave behind? Sweet action. So what are the solutions to this equation? Nice job. One more of these, and then we transition to the hard section. Got it? And I say hard section, and really, if you can understand what we're doing right now, it just gets a little tougher because the factoring gets tough. It's hard to tell in this case, where's our home base side going to be? So let's just think of the future. We want x, everything is based on where will x squared be positive. It's not about left or right or what you like better. It's about where will he be positive. If I move by adding the 2x squared across to the right, how many x squareds will I get? I don't want that, do I? So like we've learned with equations in the past, it's really important this time to understand who's smaller, -2 or -3. And -3 is smaller. Therefore, we have made our choice that we're going to add red across, we're going to subtract yellow across, and we're going to subtract green across. The direction that we go, again, is not a matter of what we like. It's a matter of where can I make sure x squared is positive. Okay. So how many x squareds will I have over here now on the left? 1x squared. So I can just put x squared. Lovely. How many x's will I have? Nope, none. Because when I move Mr. Yellow, he goes negative, minus, goes away, cancels. And what will my constant term be? What will become of minus 39? He'll be negative 49. And again, this is not all quadratics or two sets of parentheses, normal thinking. Like this one is kind of normal, but this is missing its middle term. Look at right there. It's missing that. So this is different. This isn't pull anything out. What's this one? How do I make these funky ones with the missing middle term? Definitely a positive and a negative. And how do I make the middle term not have to be there? You guys are whispering at me a lot. I wish you would just speak louder. Sevens, that a boy. We want the numbers to be opposites of each other so that the middle term goes away. So the solutions are x equals -7 and x equals +7, like that. Got it? Okay. If it weren't for having to miss the morning, I would probably end the lecture here. But because I won't be here to teach you in the morning, I have to get through the rest of this. So I apologize for the brutal notes. Would you guys like a short break before we press on? Want to take a couple minutes? I'll pause the video and you guys can just maybe grab a drink of water, stretch, do some jumping jacks or something. All right, so these get harder now. Hope your break was nice because the number in front is not 1 anymore. So this has to be a section on any lesson because I would be remiss if I made it seem like all quadratics start with x squared. They don't. They start with 2, 3x squared, 6x squared, stuff like that. So let's get through these last few. We're not going to have a lot of work time today, but oh well. So this you'll remember about factoring makes the problem significantly harder because we're not just looking for numbers that multiply to make -12 and add to make 5. The 2 really screws things up. So when we build our shells, we have to give full respect to the 2 by remember putting not just x and x, but 2x and 1x. What are my signs going to be? Positive and a negative because they multiply to make a negative. And that's just one of those things that I'll talk about again and again and again and again and again and again and again until you all hop on board with the fact that it's all about the number I've circled in yellow. We are slaves to that guy. If he's a negative, there's one of each. If he's a positive, there's 2 of the same. End of conversation. So I'm just going to guess and throw in a plus and a minus, like maybe put a minus here and a plus here. Who knows? We just know there's one of each. And what numbers are you thinking of that multiply to make 12? Sure, let's try a 3 and a 4. So like if I put a 4 here and a 3 here, this is where factoring gets a lot harder because It's just not obvious. It's not just going to jump out at us, right? So the thing to be good at this is we remember we have to test Mr. Purple and Mr. Green. And no matter how many times I draw Mr. Purple and Mr. Green, some people fail to see that that's what this is all about. Get yourself some colored pencils if you need them. What do the purple ones in the middle make? -4. What do the ones on the outside make? -4 plus 6 is not 5. And I'm trying to get 5, so we'll just chalk that up to a failure. So maybe let's stick with the 3 and the 4, but let's put them in a different order. So rather than 4, then 3, let's try 3, then 4. What does the purple in the middle make? -3x, right? And then what do the greens on the outside make? And if you add -3x and 8x, you get jackpot. So that means now that our factors are correct. So the factoring is done, but that begs another question. What makes this red thing equal 0? What makes 2x minus 3 equal 0? Well, let's find out. Let's solve it. How do you solve that little sixth grade equation over on the right? You add 3 to both sides. And then you divide by 2, and what do you get? X equals 3 divided by 2. One of our solutions is a fraction, 3/2. And we could have seen that without doing all this work over here. But I'm going to do that work with you for a little while until we see the shortcut. And of course, this one's easy. What makes the purple one equal 0? Good. So those are your solutions. X equals 3/2 and x equals -4. Let's practice that again. Right, the wrong guy there. Whoop, there we go. In your warm-up assignment today/tonight, if you choose to do it tonight, the Delta Math assignment does not have any of these, but the assignment you'll be working on when I'm down doing job interviews tomorrow will have these. So make sure you ask if you're not sure what's going on. The Delta Math is kind of a little warm-up assignment for you. It should take about 20 minutes or so, I think. Here we go. So we're going to factor. It's already ready. It's set equal to 0. We're going to build our shells. We're going to stick in a 3x and a 1x. What are the signs? One of each. You're darn right, Morgan. Got to be one of each because they multiply to make that negative in the back. This has nothing to do with the 8 in the middle, does it? Okay. So what are we thinking of? What first comes to mind if we stick in a positive and a negative? What are the first numbers you think of? Do you need us right now? What are the first numbers that come to mind? 4 and 4 come to mind for me, so I'm going to stick in a 4 and 4. All right, let's see what happens if we do that. Maybe we had success, maybe we didn't, but factoring is all about just accepting that sometimes you hit and sometimes you miss. What does Mr. Purple make? X. What does Mr. Green make? What is 4 plus -12? That's definitely -8. And I'm like, snap, I didn't want -8, but I did want 8. What does it mean? Switch the signs. Remember, don't move anybody. 3x, 4x, 4. You guys are all right where you should be. But we know now, because we got the right number with the wrong sign, that plus and minus should be swapped to minus plus, and that solves our problem for us. So let's see what you learned from the last example. Let's see if you can spot the shortcut. What makes this red thing equal 0? Nice job. Morgan found the shortcut. Good job. Basically, the way I always say this, if you didn't see it as quick as Morgan did, take a look at this. If I erased this 3, boop, then what would make the red thing equal 0? 4. X equals 4. But then the trick is you always just have to divide, boop, by the number that's in front of us. Easy peasy. What makes the purple thing equal 0? Okay, let's practice again. And then we'll do the trickiest ones, and then we're done. And you made it through the lesson. Yeah, what's up?
Find the first, isn't it just putting the second number on top of the first one?
Yeah. Yep. That's all it is. And then, of course, remembering to change the sign, right? Because we got to do the opposite thing to make the 0. Yeah. How many do you want? Well, got a little bit more, but you guys are doing great. How about this one? There's some good news on this problem. The first good news is that there's only one way to make 2x squared. That's easy. What's the other good news? Yeah, there's no negatives anywhere. That's always nice. I can just stick in a plus and a plus, and that's pretty stress-free as far as I can tell. 7 and 5 ought to be the numbers that come to mind for you. Now, the question is it 7 then 5, or is it 5 then 7? Can you tell? There's a reason to put the 7 here, because when I do Mr. Green here, what do those make? Ah, that's nice, right? Oh, wait, that's not going to work, is it? I was so excited. That's a fail because Mr. Purple comes in and says, sorry, I only got 5 X's. Crikeys. Let's try it the other way. I don't actually think this one's going to work. I think I messed up when I wrote this problem. By the way, this would be an example of a problem that we would have to use the quadratic formula on. So let's change this middle. Here, let's cheat. I'll change this for the lesson later today, but I'll leave it on the recording because I like making a fool of myself. Let's change it to 19. Now, what does purple make? And what does green make? Ah, there's what I meant to put. I'll have to make a note of that. All right, so we did it. We got the factoring after your teacher fixed his boo-boo. All right, here it goes, guys. What makes red equal 0? Negative second number over first number. What makes the purple equal 0? Nice job. Look, there's only 4 more, Addie. We're not going to get to all 4. I'm going to give you a really hard one. You're welcome. I'm going to blow through the last 3 examples after this just so I can get them onto the recording. And then you guys will be tons of work time tomorrow. And I'm going to shorten the Delta Math assignment for you. And I'll shorten the worksheet tomorrow as well to try to give you a manageable, reasonable amount. I'm assuming that you'll go and do some work. I'm sorry, I don't ask you usually to do work outside of class. I'm going to ask you to do some work today/tonight, right? Just to help us stay on pace. So not a lot, 20, 30 minutes. That's some of your teachers give you that every night, I think. I don't hardly ever ask you to, so that'd be nice. All right, so we're going to move all of our x squareds to one side. Do we want to move to the left or move to the right? Move to the left because I want to make sure my x squared turns out positive. So I'm going to take this and add it across, and that'll give me 4x squareds. That's bad news. And then I'm going to take this yellow guy and subtract him to the left. The plus 7x isn't going to change. What am I going to have at the end? Yeah. This is absolutely as hard of a factoring problem as I will ask you to do this year. So this is the top of the mountain as far as difficulty is concerned. And the reason is because the 4 in the front could be this template, or it could be this template. And to make it even more poopy, the number 36 can be made quite a lot of ways, right? So the first ones that really should come to mind are 4 and 9 because they're the closest together. So let's hop in and try a 4 and a 9. Where do you want to put them? Second one, so you want like a 4 here and a 9 here, and maybe put like maybe a plus and a minus, or let's do a plus like that and a minus like that. Does that work? Without me drawing purple and green, you should see that it does not work. The two in the middle make -8. The two on the outside make 18. -8 plus 18 is 10. So that fails. Sorry about the fly over there. Shyla really likes you, apparently. All right. That's a whopper. I know this thing it's breaking FAA regulations, I think. It's so big. It needs to get clearance from the tower. Yeah, it's here to spy on us. Let's try I don't know. Let's try this. I mean, we're still just trying to make 36, right? What do the two in the middle make? -9x. What do the two on the outside make? And -9 plus 16 is, hey, we got it. So I can erase this template on the bottom. He proves now to not be the winner. The winner is the 4x, 1x template, just like we have it set up. So here we go again. What makes the red thing equal 0? Positive second number over first number, 9/4. And of course, what makes the yellow one equal 0? Just -4. Just -4. I don't know what just happened back there, but I'm glad we all got to witness it. You okay back there? Okay. So I have to go through these last ones pretty fast just because I want to make sure, like I said, at least I can get them onto the recording. And if you would like to go through them again, then you're welcome to. Here we go. So I got about a minute for each of these. So bear with me if I go too fast. Just go watch the video, pause, rewind, take your time. This is one of these funky ones that does not have anything at the back. So what we're going to do is we're going to pull X out because that's all they have in common is I'm going to pull out X. What's that going to leave behind if I pull out X? What's left of 3x squared if I pull out an X? 3x is all that's left. The 3 is still there and one of the x's are still there. What's left of this term if I pull out the X? Sweet. And so just like before, what I have now is an interesting situation where I've got that weird XE lonely guy and then the binomial guy. What makes this one equal 0? Always. And then now that you know this, you got mad skills. What makes green guy equal 0? Dude. And then I think this will probably be, I think I lied. I'm going to do one more. This will be it. You guys are amazing sitting through this on a Monday morning. This is one of the funk monsters that is missing its middle term. And for the, I don't know, 4th or 5th time today, I'm going to ask you this question. How do I make that middle term go poof? A plus and a minus and numbers placed strategically to make sure that everything in the middle cancels out. So I don't want to consider multiple templates this time. I know the only way to make this work is to divvy half here, not half here, but square root. And then what's the 25 breakdown that we want? Awesome blossom. All right, let's do this again for the 12th time. What makes this equal 0? -5/2. And what makes this equal 0? So your assignment that I'd like you to do tonight, I understand that not all of you will. I don't like it, but I understand. It's going to be on Delta Math, and I'm going to shrink it down for you. It had 20 or 25. I'm going to knock it down to like 10. So you should be able to get that done before you get to class tomorrow. And then tomorrow, remember, I'll be in the building, but not in this class. I might be here to get you started. You will have a paper assignment tomorrow that will be harder than the Delta Math. Got it? Sweet.